Foundations of amateur radio. If you've ever been on the hunt for an antenna, and let's face it, in amateur radio that's pretty likely, you'll get information about the gain of an antenna. Often someone will tell you that this one has 12 dB gain versus that one which only has 9 dB. As an aside, I've seen a few videos where people are comparing sound levels and mention that without the fan, there's only 3 dB less noise. What they don't realise is that 3 dB means half the noise. The same is true with an antenna. That 9 dB antenna has half the gain of a 12 dB antenna. In the past I've talked about gain. It's always in comparison to something else. If I say that antenna has 12 dB gain, I'm actually saying that antenna has 12 dB gain when compared with an isotropic source. To jog your memory, an isotropic source is a theoretical source of electromagnetic radiation. It cannot actually exist. It radiates uniformly in all directions. Now when we talk about gain, we're saying that our new funky antenna radiates better in some or other direction than an isotropic source. As a consequence of this, it also means that it radiates worse in other directions. So antenna gain is a trade-off between radiating everywhere like an isotropic source and only radiating in one direction like a laser beam. As an aside, a laser beam could be seen as an antenna for light. It radiates much better in one direction than in any other, and given that light is also an electromagnetic radiation, we're still playing in the same area of physics. If you've ever shone a torchlight onto a wall, you'll have noticed that the light isn't uniform. There are brighter and darker areas. It's the equivalent of differences in gain. Some bits of the light are amplified more than other bits. If you compare it to something like a candle, not exactly an isotropic source but remarkably close, you'll notice that the light is uniform. A torch doesn't shine from the rear. The energy from the light that's missing from the rear comes out the front, and that's gain. Radio antennas do the same thing. In order to compare antennas with each other, we've devised several tools. The most common is a polar plot. It's a circle that is divided into 360 degrees, and inside the circle are concentric circles with gain numbers attached to them. Often, but not always, the outside circle has 0 dB as a value, and you'll see minus 10 dB, minus 20 dB, and so on as you get closer to the middle. Weaker signal is drawn away from the outer edge, stronger towards the edge. No signal in the middle. As you walk around your torch, you could record the strength of the light. Where it's strongest, you make a mark on the edge of the chart. Where it's weakest, you'd mark towards the center of the chart. If you were to take your torch and take a slice through the middle of your battery, through the reflector, through the globe, through the lens and out to the wall, you'd end up with what a polar chart is displaying. Of course, you can slice through your torch in any direction and make a chart, but traditionally you'd slice it horizontally and vertically, or azimuth and elevation. And if you can't remember which one is which, an elevator goes up. A torch is generally symmetric, so both charts should be the same, unless your reflector is a weird shape, at which point the two charts will likely be different. Antenna charts work the same way. The polar graph is showing the signal strength as you walk around the antenna, twice. Once for the horizontal slice and once for the vertical one. As I said, the outer edge of the chart is set at 0 dB. This is because you need to compare full signal to less signal. If you're comparing multiple antennas and they all have the same 0 point, you can draw them over the top of each other and see their differences. This allows you to compare wildly different antennas with vastly different amounts of gain. I must also point out that you can get more signal strength in two ways. More gain from the antenna, but also more power into the antenna. This means that your choice of antenna is dependent on what gain you want and how much you're prepared to pay for it. I could light up an omnidirectional antenna with 300 kilowatts, or I could use a very high gain antenna and use 5 watts. It all depends on your purpose. Final comment. Beam width of an antenna, the main direction of radiation, is often based on where the signal strength is half. so 3 dB less than the maximum gain. That location will determine the angle. Remember, the chart is expressed in 360 degrees, so you'll be able to see the beam widths on the same chart. Polar charts, lots of hidden meaning inside a pretty picture. I'm Onno, Victor Kilo 6 Foxtrot Lima Alpha Bravo.